Today we're going to talk about improving sow lifetime productivity. And this effort really began back in about 2010 as a way to encompass many different departments within the science and technology area at the National Pork Board. So we put together a research effort in improving sow lifetime productivity, and I'm going to talk today a little bit about some of the results that are starting to come back from that effort. I like to start off these talks with a definition of what exactly we are talking about when we talk about sow lifetime productivity. We assembled a team of people from the industry, investigators, allied industry members, and they beat around the idea of what the definition of lifetime productivity actually should be. And they came up with this one. It's the total number of quality pigs that a sow weans from the time she becomes breeding eligible until she leaves the herd. Okay? And so you can imagine that there's a lot of factors that affect sow lifetime productivity. The key drivers to it are sow retention and the number of pigs weaned per litter. These other factors also play into sow retention and or the number of pigs weaned per litter. So we got the research group together and we talked about ways to approach basically sow retention and number of pigs weaned per litter. And of course, litter of origin date information is important in that as well. So many of the studies that I'm going to talk about today, they actually collect information from the time a female is born and track her out through sixth parity. And they collect all kinds of different data relative to her litter of origin. And so things like they collect a tail or an ear clipping for genotyping later on, because we'll have all of this phenotypic data on these individual females. It would be nice to be able to genotype them and find the genes that are responsible for some of this variation in lifetime productivity. They capture information on the male to female ratio in the birth litter. They draw a blood sample for immunocrit, and I'll talk about this particular assay in just a little bit, but it's a way of measuring the amount of colostrum that a female consumes right after birth. They'll collect data on number of fully formed piglets, number born alive, the dam ID and her parity, individual piglet birth weights at day one, number of pigs weaned, and then weaning weight for each of the individual piglets too. So on these very large-scale projects that I'm going to be talking about today, where you have 1,200 to 2,000 females on each individual treatment, this is a lot of data to collect from the time that female is born until she leaves the herd or reaches out to sixth parity. What are some of the challenges associated with sow lifetime productivity? Well, first and foremost is everybody likes to collect pigs per sow per year, right? That's the hot and sexy number. Everybody wants to claim that they've got 30 pigs per sow per year. But it really doesn't capture the entire story, because there are some things that you can do to kind of fudge the information relative to pigs per sow per year. And it doesn't take into account the economic impact of that sow. And so we typically don't collect information on sow lifetime productivity. It's not commonly available in most sow record systems, although I do know that PigChamp record keeping system has the capability of calculating sow lifetime productivity now. But generally, it's not available. There's a policy in some companies of culling based on a sow's parity. So when sows reach sixth parity, they automatically cull that female. And so you don't get the advantage of keeping her through the eighth parity or ninth parity or 10th parity, which is when some of that productivity really manifests itself. And then, of course, the great big huge one is the fallout of early parity sows. Those females that get selected to be replacement gilts in the herd but never get bred for a second time, okay? And this graph actually shows that quite well. So what I've got graphed here is the percentage of females on the left-hand axis, and then the number of piglets that those females have along the bottom axis. And you can see that 28% of the females have between 0 and 9 piglets, and 14% of the females have between 10 and 19 piglets in their lifetime. This results in 42% of the females that we select for breeding that actually have 19 or fewer pigs, right? So then there's only 60 some percent left over that would produce pigs out in these larger lifetime productivity areas. So it's a big problem having sows fall out before you can realize the full potential of those females. And this graph just shows it a little bit better in a slightly different way. There's variation within the amount of sows that are retained, even within the same system. So this data comes from a large production company, and they looked at their best farms in sow retention, and they looked at their average farms, and they compared how their best farms did to their average farm. And from the time they were selected out through sixth parity. And you can see quickly that the pigs from the best farms, the sows from the best farms, are retained at a much, much higher rate. Out here at sixth parity, we've still got over 40% of the females in the herd, and for the best farms and for the average farms, we've got just over about 25% of the females are still in the herd. So the rate of change between these for each event, 4.5% of the females are called at each event for the best farms, whereas 5.6% of the females are called for the average farm. And of course, if I've just graphed best and average on this particular chart, the worst farms would be down in here, right? And so there's a lot of variation. This is just within one system. Think about the amount of variations that there is within the whole industry. So if we were to compare farm to farm to farm, there would be a substantial amount of variation in sow retention over time. So the research goal that the consortium came up with is to conduct research that will improve sow lifetime productivity by 30% by the year 2017. Essentially, that means we need to increase pigs per sow lifetime from 34 to 44. So there's an increase of essentially 10 pigs over a sow's lifetime. What's the easiest way to do that? Anybody? One more parity, right? Keep her in the herd longer, prevent that early parity fallout, keep those females in the herd longer, and you'll achieve that goal. So that has to do with gilt development and retention, right? So the research group said, well, let's talk about, let's investigate optimizing gilt growth and social interactions, gilt competency based on the selection criteria of those females, their immune status, and immune markers that show up in their blood. And then sow retention basically boils down to strategies that minimize body depletion over time. And the other side of that equation is to increase the number of piglets weaned and the viability of those piglets. That has to do with sow lactation and gestation feed, nutrition, milk quality and quantity, particularly in the area of colostrum, increasing farrowing rates, strategies to minimize pregnancy loss, and then mitigation of the impact of seasonal infertility. And this actually has a very large effect on our sow lifetime productivity, because everybody knows that because of the heat stress that occurs in July, August, and September, we have farrowing crates that go empty in the months of October, November, and December, right? So because of seasonality, we greatly or dramatically hurt our sow lifetime productivity. How do we overcome that? How do you guys overcome that are producers? Say that again? Yeah, so you overbreed by keeping more gilts than what you actually need to if you didn't see that dip every year. So people typically breed 10 to 15% more females than what they actually need, and that's an incredibly inefficient way to go about it. What are some of the research challenges associated with this? Well, these are very large-scale projects that last over multiple years. If you're going to follow a female from the time she's born out through at least third parity, it takes many years to do that. Cell lifetime productivity is multifactorial trait. What does that mean? Multifactorial simply means that there's a lot of different things that go into making that trait. So things such as floor space requirement, genetics, nutrition, health, all of those things play a part in sow lifetime productivity. And of course, those sorts of studies that are large-scale, multi-year studies are extremely expensive, and therefore no other funding agencies, such as the USDA, are even looking at this particular problem. So we assembled together a team of investigators. We entitled that team the Research Consortium for Sow Lifetime Productivity. Each one of these investigators was selected for a particular reason. For example, Ken Stalder from Iowa State University is our geneticist and a very good statistician. We're going to be generating a lot of data, and so he's on board to analyze that data. Natalie Trottier from Michigan State University is a mammary gland biologist, so she studies how the pigs get nutrition through the mammary gland. Billy Flowers is a well-known reproductive physiologist from North Carolina State, and he's on board to be a reproductive physiologist specialist. And then we've got multiple universities that are involved, Iowa State, North Carolina State, University of Alberta. George Foxcroft is a professor from the University of Alberta, Michigan State University. We've engaged some industry partners to help us with these projects, mainly because to run a trial of this scale requires lots of females, and university farms typically don't have that, but the production companies do. So we're doing work with Murphy Brown, Holden Farms, and Carthage Veterinary Clinic. And then we've got a large contingency from the U.S. Meat Animal Research Center. These investigators here are heavily involved in the sow lifetime productivity effort. And beginning in 2011, we started to fund research projects. So I've just put their ID number here on the left-hand side and the titles across the top. I'm not going to read through each one of these, but I did want to draw your attention to a couple of key things. The first is the fact that we are doing some of our projects related to management of those females. We're doing some projects that are related to the diet of those females, and then we're looking at the impact of heat stress in these females. And so we're doing those types of projects that I talked about. We're funding those types of projects that I talked about a little bit earlier. If you come this afternoon, Tim Safransky at 1:30 is going to be talking about this particular project here, the impact of in utero heat stress on subsequent growth and composition, reproduction. We then took those females, those gilts from these that were born to heat stress litters, and we actually are funding a second project at Virginia Tech that is looking at those females, carrying them out and measuring their performance and their offspring. So those are kind of a research story there that we're telling. The last thing I would like to point out is a couple of these larger studies. 12-210 is one of those very large-scale multi-year projects. We don't have our research results back from that particular project yet. And the other one is this 14-149 down here on the bottom. That's the one that's being conducted up at Holden Farms, where we'll look at strategies to improve social interactions with gilts and optimize that genetic potential for reproductive physiology for those females. So then let's just talk about some of the research highlights. The first research project I'd like to talk about was a litter of origin study that we did, funded through us. at North Carolina State University by Bill Flowers. And so this is some of the data that he generated. He simply took gilts from litters, and he balanced, within 24 hours, he balanced the litters to either contain 7 piglets or greater than 10 piglets. And he did that simply by removing the barrows from the litter. And then he looked at various aspects of reproductive measures. So in this particular graph, he shows the farrowing rate here as a percentage across the different parities down here along the bottom. And it's plain to see that sows that are born and lactated in small litters have an increased farrowing rate compared to sows that are raised in larger litters. And the same holds true for the number of pigs born alive by those females. In fact, over 6 parities, sows that are born in litter, that are raised in litters of 7 piglets or less, had a half a pig more than those sows that were raised in litters of 10 piglets or less. So that's pretty dramatic results, right? We're not exactly sure how to implement those results on under a commercial condition where there's other considerations. But it may be possible at some level, maybe multiplication farms, where you could remove those boars from the litters, decrease the number of gilts that were suckled by that female, and over her lifetime as a sow, that female would be more productive. The real kicker on it, though, is that those females that are born, that are suckled in litters of 7 pigs or less, are retained at a much higher rate than those females that are born in much larger litters. So there's a substantial difference between those females that are born that are raised in smaller litters. This has huge value to retain those females over a longer period of time. Remember, I said that was one of the easiest ways to increase sow lifetime productivity. Well, what about the effect of birth weight on longevity? How long that female stays in the herd? And again, this comes from some of Dr. Flowers' work, and he basically followed those females through 6 parities, and he divided them out based on birth weight of either 3.6 pounds versus less than 2 pounds. And there's the most dramatic observation on this particular slide is that those females that are born at less than 2 pounds, while they may be selected to be sows in the herd, fall out at a much greater rate to their rebreeding after first parity. So there's a big difference in the rate at which those females fall out versus females that are medium to large size at birth. So that should tell you, don't keep your small pigs, right, out of your gilt litters. And so I don't really know what to do with this slide because it talks about immunocrit and it fits in with birth weight and piglet growth. And the way it fits in with that is because the small piglets tend to drink less colostrum, have less opportunity to drink colostrum. This immunocrit that I'm showing along the bottom here is the assay that was developed by Jeff Valet, and he measures that within 24 hours of birth. He draws a blood sample. He spins that blood sample down, and then he measures the amount of protein that is in there. And the amount of protein in a piglet that is 24 hours old is mostly due to immunoglobulin, which it gets from colostrum. Okay, so he can correlate the immunocrit reading with how much colostrum that female has consumed. And he found out that when he looked at incidence of puberty failure, 10% here versus 2% down here, those females that actually consumed colostrum along the bottom axis, those females that consumed colostrum came into puberty and actually had a pubertal estrus and were successful in being bred. Colostrum ends up having a lot of things in it. Besides just immunoglobulins and energy for growth and through its fat, It also has growth factors, and some of those growth factors target specific tissues, one of which is the uterus and the ovary, reproductive tissues. And the uterus and ovary growth are important for being able to shed lots of eggs and then to have the uterine capacity to raise those pigs over time. What about the effect of nursery floor space on sow productivity? This project was conducted by Mark Estienne at Virginia Tech. We funded that project back in 2011, and he basically looked at the effect of floor space allowance during the nursery period on female growth and then subsequent reproduction. It's fairly well known that in gilt development, floor space is important for growth, but it doesn't really translate over to reproductive effects, right? And we wanted to see how far back you would have to go to crowd those females and see if you could get an effect on reproduction. So that's why we did this particular study. He divided the piglets out based on their birth size and put them in the nursery. They had substantially, based on birth size, they had substantially different entry weights into the nursery and different exit weights into the nursery. And of course, their growth rates were different in the nursery, okay? So growth rate turns out to be very important in sows being fertile and being able to be maintained in the herd for a longer period of time. So growth rate, again, this tells us that we don't want to keep those small females because they're going to grow more slowly. When he impinged floor space requirements on those females at 1.6, 2, or 2.9 square foot per female, he measured growth rate for them, and average daily gain, final body weight, average daily gain increased at a very linear type of fashion and was significantly different. And so we got the growth rate effects that we were looking for that we see in the development phase. We got those growth rates to show up here in the nursery period. The funny thing is that doesn't really translate. While growth rate translates in square footage in the nursery translates into slower growth rate, it doesn't really translate into effect on reproduction. So in this study, again from Estienne, he looked at different floor space requirements here for those females. He's got the number of gilts, and then he followed them out through 3 parity. And if we just look at the summary down here, total born and total born alive, there's really no statistically significant difference between the 3 different treatment groups. So again, we can crowd those females in the nursery a little bit, provide them with a little less floor space, and we don't really see a significant effect on the reproductive side, just like we see. That's just like we see in the during development. Okay. What about developing a physiological test for sow longevity? Wouldn't it be great if we could make an observation when a gilt is pretty young and then decide, based on that observation, how long she would stay in the herd or predict that? And so Billy Flowers began to an experiment. Again, we funded this in 2011. Where he looked at developing a physiological test for those females. He took females that, again, were from a litter of less than 7 piglets, and when they were entered into the herd, he then either exposed them to boars or he gave them a low dose of PG600. So the low dose of PG600 shows up in either the open circle or the open box. And then he looked at response. And he judged response based on the redness and swelling of the vulva. And those gilts that experienced a red swollen vulva within a few days after boar exposure or half a dose of PG600 then were determined to be responders. And the responders are shown here in the solid line. I'm sorry, the responders are shown in the top lines here, okay, the circles. The ones that didn't respond to that then are shown in these boxes down here. And this graph clearly shows that those females that responded either to boar exposure or a low dose of PG600 beginning at 140 days of age stayed in the herd for a much longer period of time than those females that didn't respond either to boar exposure or to PG600. So essentially you could give a half a dose of PG600 to your replacement gilts at 140 days of age, and you could predict the incidence that they would stay in the herd over a longer period of time based on their response to that. He looked also at those gilts from larger litters to see if the same principle would hold true, and indeed it does. Those females that respond to either boar exposure or PG600 are shown here in these circles, and they are significantly different than those females that did not respond to those two treatments, regardless of litter size that they were suckled in. So there's a lot of talk about when is the best time to relocate gilts into gestation or breeding crates prior to them being bred. And so Rob Knox at Illinois conducted a study looking at the timing of relocating those females into breeding crates before they were bred. So he relocated those females at different time points. So he relocated them 1 week after their first estrus, 2 weeks after their first estrus, or 3 weeks after their first estrus. So the other way to look at that would be he relocated them 3 weeks before their first breeding, 2 weeks before their first breeding, or the week of their breeding, right? So he was looking at the timing with which they relocated because of the stress that is involved with moving from a pen situation to a gestation or breeding crate. He took measures of reproductive efficiency over here on the left-hand axis. He looked at things like number of services, their conception rate at 4 weeks, farrowing rate, total born per litter, pigs born alive, and then the gilts rebred within 7 days after their first parity. And essentially he found no differences between any of the measures that he took between the treatment groups. So it's from this data, it can be determined that it's safe to relocate your gilts anytime after their first estrus is detected up until the week that they're bred. So what are some of the things that I wish for you to take home today? First is that improvement in sow lifetime productivity substantially impacts the profitability of all phases of production. Because if you think about filling those farrowing crates, having large litter sizes, that really drives the whole productivity of the entire enterprise through the nursery, through the grower, and through the finisher. Litter of origin has a substantial effect on sow lifetime productivity. Billy Flowers' work at Florida, Jeff Vallet's work with the Immunocrit have determined that. And then gilt selection, development, and management strategies are one key to improving sow lifetime productivity. And to this point, that's really where we've been focused. We've been focused on the gilt development side. Going forward from here, then we hope to focus more on mammary biology and piglet growth and viability before weaning. I would like to point you to a couple of resources that the Pork Board has available. You can look those up by going to the pork store, and you can get those resources as a producer. They're free to you. You just sign up for them, and they ship directly out. We've got a replacement gilt evaluation pocket guide that looks at underlines, vulvas, feet and leg structure. We've got a heat detection poster that we just renewed this year, and that looks at methods for determining heat in females. We've got a sow body condition scoring poster. Seeing What You Feel is that poster is a pretty old poster, but it really never changes. Basically, it's a cutaway of a sow reproductive tract with a piglet in there, and then it shows a hand reaching in to adjust that piglet and help that sow give birth to the pigs. And then the selection guide poster set is a combination of different guides that go together in a poster form, so you can post them in your barns. Finally, there's two other things that I'd like to leave you with. The first is that in the April Blueprint issue of the National Hog Farmer was entirely dedicated to sow lifetime productivity. I've only highlighted a few of the research projects that we've completed associated with this. Also, there's lots of our projects, because of the nature of the projects, they're long-term. We don't have the results back from them yet, but their results are starting to come in. And so we partnered with National Hog Farmer, and I think we put in 8 articles in the Blueprint series, all related to the projects that we funded on our sow lifetime productivity effort. I've got copies of those over here on the board, on the table, if you didn't get one in the mail. I would suggest that you take that copy, look through it. Inside there's a poster. The heat detection poster is inside there. Look through it and then sign up to receive the National Hog Farmer. That would be my suggestion to you. And then, by the way, that came out way better than I thought. You know how sometimes you think you have this idea of what something's going to look like in your head, and then it never really turns out to be like you imagined? Well, on this particular project, we started thinking about it back in September of last year, and it really turned out way better than what I thought it was going to. And so I was very, very pleased with that reporting of the research in that format. And then finally, the research results for this project, but also projects in swine health, projects in well-being, information in projects that we've completed in nutrition and seasonality. Those projects show up if you go to pork.org and use the /research. You can pretty much search for any type of research project that we funded, and you can get information on the results of those projects.